scientists who are participating, and just as an example of this, while we're concluding the benthic portion of this dive, the next portion of it is a midwater portion.
For a couple hours.
For a couple hours, and it's actually going to be led by a couple of our scientists on shore.
Yeah.
Yep.
Amanda, taken over for us.
Right, Amanda Netburn is one of them. She's she's multi-cruising. She's on the exploration vessel Nautilus.
So she's on another ship in another ocean?
Right.
There's your globe.
Okay.
Okay.
Right. And Liz Shea from the Delaware Museum of Natural History is also going to be helping to lead this portion of the dive.
Yeah, that would be nice.
Well, thanks for the nice introduction. I'm really looking forward to it.
Yeah, once I can recognize D2 in that
everyone.
Just see it go right now.
That was a great dive. Really had fun.
Yeah, we still got you pretty strongly in sonar now.
I think I'm underneath you. I need to push forward.
Okay.
Well, that doesn't make sense.
Yeah, I had so much
down
fun.
a little bit.
That was great.
Oh, there you go.
That's right.
Yeah.
Okay.
And you're still roughly right here on Sirius's sonar.
Okay, so I need to come to the right.
Yes.
Pilot, this is watch lead.
My lights are off. That's correct, yeah.
Oops.
Okay.
Pilot?
Yes, watch
Pilot,
lead, go
this
ahead.
is watch lead. Okay, we would actually like to start, finish this portion of the dive, the benthic portion, and start the midwater transects.
Yeah, we're ready to start the midwater.
All right.
Get yourselves in position.
Yeah, what do we need to do? Because we got to get over to the position to start it. So thanks everybody for following us on the benthic portion of this dive, looking at the volcano that erupted in 2014.
Stick around for the midwater portion. This might be a good time now for Amanda and Liz. And now I see Sonia Rowley, and I'm not sure if you're participating in the midwater portion or not. But Amanda, why don't you introduce yourself, tell us your affiliation, your expertise, and then after that we'll have Liz do the same.
So, shall we come up together?
Sure.
Roger that.
My name is Amanda
Ready to go?
Netburn. I
Yeah, you start up and I'll
There we go.
at OER, and I recently received my PhD from Scripps, where I studied mesopelagic fish and their interactions with oxygen minimum zones off the coast of California. And I became interested in learning more about the interactions between synthetic environments and the pelagic environment, which is a really
do we have a target depth for the midwater?
Area of science. And so proposed this dive that we're doing today, and I'm really excited to
Any
find
ideas
out
what's going on with the midwater?
I'll find
Thanks,
out.
Amanda.
I don't know anything right now.
Liz,
If you find out, and then you can...
Sure.
introduce yourself.
Perfect.
Watch
My
leads,
name
Nav.
is Liz Shea, and I'm the curator of mollusks at the Delaware Museum of Natural History in Wilmington, Delaware.
Watch leads, this is Nav.
I'm kind of interested in all things cephalopod.
Okay.
I've worked for many years with Mike Vecchione, so those of you who follow the Okeanos, I'm sure have heard his voice on a regular basis. And I'm standing in for Mike and
back
Mike's
on
board,
the west side.
hopefully able to help annotate some of these midwater transects. Hopefully.
One second, let me try to find out where it even is.
I'm not
sure.
sure.
There, it's way over there.
It's a little murky now.
Do we have a depth that they want?
I heard you, Rolly.
Okay, I see Sonia Rowley. Okay, so Sonia's probably not on the phone
pilots,
line
that's at a depth of 410.
Anyone else want to introduce
410?
themselves?
Yes.
410 on the...
At the bottom over there where we want to go. Right over here. We got 410.
All
right, so how high do we have to get to be clear of the crater?
Well, it's going to continually go up to there. So
Casey,
the crater.
you can introduce yourself.
Let's see.
Hi, I'm Casey Cantwell with NOAA's Office of Ocean Exploration and Research, and I'm going to be filling in for our watch leads on the ship while they go and work on their summaries and sampling.
Actually, yes, I'm going to go do some spicular preps, but I'll be coming back
just
and
had
forth
an overhang.
and to see what's going
At
on.
about 395.
Okay.
Well,
See y'all later.
0, 3,
Right,
9,
bye now.
10.
So Liz and Amanda, while we are moving into position, we've been running the EK60s for a a bit. If you would like to see them, we can have them put up on one of the video feeds.
Right here is 390, but I mean, clearly we're going to have to go higher.
Yeah, it looks like you're moving away from it now.
Yeah, it might be a little complicated for me to access it.
Yep.
Well, Liz, would you like to see them?
I'm kind of amazed I'm getting the speed at all. Would you mind describing what you're saying?
Yeah, give me a second.
You're still barely aglow in the upper screen there.
All right.
EK60 is now full screen on screen 3.
Gotcha. Yep. Hold on one second, guys.
Okay. My sonar is clearing up now. There we go.
Sure.
All right, so the EK60s are showing a fairly consistent level of biomass throughout.
Really fascinating.
Okay.
Yeah.
So the EK60s are showing a fairly consistent level of biomass throughout the water column right now.
35 meters via high back.
Pretty much from our bottom depth where there's quite a bit of activity, which I think is actually a reflection of the acoustic bubbles, versus up at the top you've got a little bit of stratification. Around 100 and change, just above 200, and or just below 300.
Go ahead, Bridge.
And so that's in the 18 kilohertz. 70 kilohertz has just basically is picking up biomass at the bottom.
Okay, so we're going to tow over to that
and
place.
120 kilohertz is picking up a little bit of biomass at the bottom, but mainly interference from the USBL sonar. And the 200 kilohertz is just picking up a little bit of biomass at the surface.
Copy that. You're actually clear to do that now. We're out of the worst of it. Copy that. Tell me when you're done, and I'll give you a new movement.
So Carl's suggestion was that we just get
So it sounds like the bands that we have, that we've proposed to do, the 2 meters off the bottom, 5 meters off the bottom, we're going to hit. We're going to go through some of those bands, but we're not going to be necessarily targeting those specific bands.
And right now the ship's going to move around because those sources were working pretty hard, and we don't want a failure or anything while we're working this. So I'm going to let them turn first before our ship move.
What appeared to be an avoidance behavior.
Okay.
So it will be interesting to see as we work our way up through these layers what happens.
I guess we're going back over.
We're going way up here.
18 kilohertz sonar, where we can actually see
so we're just going to tow over there
the biomass moving. So we'll see what happens. It should be interesting because with this much turbidity, our light may not transfer as far and may not disturb as much. So it'll be an interesting test.
Yeah, well, we also did a very long transect at a single depth. We were
302
for about an hour. So I'm curious if doing shorter transects actually might be better for avoiding the avoidance.
Take them by surprise.
Yeah, exactly.
It's very likely.
So life's good.
Shoreside
Thanks for your help, Carl.
scientists and Casey. Question about the quad split. Is there would the sonar be less important than the EK60? Should you wish me to put a second computer display up?
The EK60 would probably be better right now ahead of the ROV sonar.
Okay, Nev, whenever the
as right
ship
now
is
it's just
ready,
mainly being used for navigation purposes.
Don and I are ready as well.
To the lower right.
Copy that. I will just let them finish up their heading
Thank you
page,
very much.
and then we'll get moving.
Yeah, Amanda, this is Jim.
So 340 is safe the whole way there, right?
Yes.
All right. I'm going to come up to your depth,
Okay.
Don.
Hey, Amanda, are you still there?
Yeah.
So Jim had a question for you.
Yeah, no, I just thought it was an observation, really. When we did the long linear transect, we changed depths a couple times, essentially chasing after the biomass that we were seeing in the EK60.
306
and
to 310.
it changed. It ran away pretty darn fast.
You still want to go
really in a
0.2
matter of,
knots?
it seemed like a matter of minutes from when we had gotten to a specific depth. The biomass that we had been observing there was gone.
If the ship's happy to, and don't overwork
I'm very curious. I'm very curious sometime to turn off the lights and try it. Of course, that wouldn't be a very useful visual survey, but the EK60 image was the EK60 was pretty dramatic in terms of watching the biomass run back to where we'd just come from.
Yeah. My understanding is that response can vary a lot depending on what the organisms are that are.
Copy that.
Sure.
I got a ship move for you here if you want to line this up
really
afterwards.
Vary a lot in composition.
175 meters, 305 degrees, 0.4 knots.
So if it's a really fishy layer, they can avoid things like the ROV really quickly. If it's a lot of shrimp and
that's correct. Just let me know when you're starting.
Lower organisms.
Kind of fish off the top.
Take longer to get around. Yeah.
Is that avoided?
Thank you.
But,
as you guys get over to your position, might I recommend that you use RVHD2 to position the lights more forward than down?
Pretty different conditions. And
Rolly,
take note of that and hopefully use that information to inform future protocols for these kinds of surveys.
Yep.
I wish I could see the tether.
Extra info.
Yeah.
Just a little uncomfortable with
Can bring the lights back on.
not seeing the tether.
I think you're still on the other side of that cloud there yet. Huh? That's still a gas plume there, isn't it? In between us?
Right. What's the distance between us on high pack?
High pack is showing 50 meters.
Okay. All right.
I think that USBL is not responding as well.
Well, as long as it's not like 10 meters, because I'm pushing out.
No, it's.
Say that again.
Yeah. See now I can see the tether
Yeah.
straight out.
Yeah, pilot. We just came out of auto heading, and
okay.
Maybe you want to also as well, or we start to tow yet? Ship moving?
It is moving.
Yeah.
It's turning still. It has not started towards its destination. They're going to let me know as soon as it should be any moment now.
All right. I'm going to stay in auto head until we're moving.
ROV light reflection is increased.
We had that one working, and I can kind of see it's just not focusing up. So I think we can turn it again. Yeah, we're able to turn it, but we can't focus it. So I don't know. That's what I can give you.
There you go.
Nice. What'd you use?
The focus button.
Teach Carl about that, bud.
There you go. All right. Yeah, I feel good about that.
That is correct.
So this is what it's like to fly with a single-body vehicle. So this is what it's like to fly with a single-body vehicle.
About to start our move.
You've got no eyes on your tether.
It is initiated.
Copy that.
Looks like the light reflection levels.
Would you like me to zoom
So for those of you that are just joining us at home, this is NOAA ship Okeanos Explorer. We're coming to you live from Daikoku Seamount. We had a really successful benthic exploration today where we've discovered a number of hydrothermal vents as well as a sulfur pond. We've also looked at the documentation of how this area has changed over the last several years since an eruption in 2014.
5 or 3? 0
and
meters.
we are currently in the process of transitioning to midwater work. So we just left the crater at the top of Daikoku Seamount and are moving basically across the crater to go back to where we saw our first active vents earlier today and where we found a bubble plume overnight. So as you guys are watching, we are transiting through the water column in order to get on station so that we can do sort of a systematic exploration of the water column over these hydrothermal vents. So bear with us. We should be over there and beginning the water column transects in about probably 15 minutes or so.
To the east. And they're moving northwest. Andy, did you get briefed on what we're going to actually do during this dive?
No, they were still discussing it, and we were focused on everything else. So I know, here's what I do know. We're going to be basically forming a ladder-like pathway, just over, horizontally, up, over. As far as anything more detailed than that, I don't know. I don't know the steps that they want to come up in, or anything like that. So I will find out as soon as. Okay, perfect.
Okay. Serious, that's perfect visual.
It finally got you in the
now,
tail camera here.
Coming out of the cloud layer.
Yep.
On the ROV.
Okay. Don, just when you say going back and forth, do you mean like lateraling back and forth left and right? Okay. Okay. Yep. Yep. Okay. Okay. Understood.
And you said those height differences were what? Oh, okay. Okay. Copy that. Copy.
Oh, sure.
It's like you're above me a little bit.
Yeah, I'm just.
Yeah, is that?
Yeah. I'm just letting myself be towed, basically.
Gotcha.
I still got Z bias on, but that should just maintain me somewhere around here. I'm not trying to hold depth or anything
Gotcha.
like that.
I didn't hear the first part of Jim's transmission. But all right.
So, Don, you and I will...
Go, Bridge. Are you talking about surface current or down bottom? I have 1 knot at 74 degrees true. Correct. Yes.
Okay.
Copy that. That will work for us because we're just going to be doing small maneuvers, if moving at all, with the ship after this move. Yeah, this is. It's not going to be like this for the rest. We're only going to have this one move.
All right. So, Don, if I understand correctly, what we're going to do is we're going to get the ship in position somewhere.
Somewhere over waypoint 2.
Yeah, where we like the bottom. And then I'll come underneath you and turn so that we're in normal survey position. And then we'll descend together. And when I get to the bottom, we want to figure out what direction the current's going. And then the idea is to make moves. So let's say that the current is flowing to the west, perfectly to the west. Then ideally we would make moves to the north, to the south, to the north, to the south, without changing Sirius's position.
Right.
The only thing you'd do would be rotate right,
right
rotate
to
left,
left,
rotate right, rotate left, and I'll just keep
running
out to the end of the tether.
Well, how many passes though? But then you're going to make one pass. Then
it'll be one pass per depth.
Yeah. So
one pass, then we rise up.
I'll do the seafloor, and then we'll come up. Well, I'm going to try altitude of 2 meters, and then we'll come up 5 meters from there and go across. Come up 5 meters. And
gotcha.
Go across. Yeah, so
all right. Again, sounds like a good plan. Something to deviate from.
Sorry, video. I was hearing too many things at once. What would you like me to do? Got it. Thank you. No, they're on. They're on.
That was certainly fascinating.
It's a good word for it.
It would have been cool to stay down there longer and really work that wall a bit.
Probably appreciate you cleaning off that black spot on my lens.
Oh, you're welcome.
Oh, wait, you didn't. Still there.
Oh, that one. I thought you meant the skid in the lower right. I just got rid of the skid for you. Now, Rolly, what were you telling me about light positioning for this?
So,
because we can go ahead and get them in position.
Yeah, what I was recommending is if you use ROV HD2 to look up at your light bars and just position the light bars as much forward as you can. I mean, you guys typically don't want to run with your light bars out.
Yeah, right.
But I believe when you guys last left them, they were sort of pointing more down than forward.
Yeah, I think it looked like about 45 degrees down with the bars in.
And also maybe look at your lower swing arms and just make sure they're as much straight forward as possible.
Okay. You got
At least while we're in the smoke, if we get out and get better visibility, then I'll request that they be spread out.
Okay, Don, you can go ahead and rotate those lights all the way up.
8 minutes left in our move.
Okay.
Copy.
Roger that.
Also looks like the starboard swing arm might need to be nudged in a tiny bit.
All right. Let me get the upper lights first. Okay, upper swing arm we wanted enabled, and we want to tilt them up. That's as far as it goes?
Yep.
Under swing arm. Upper stow. Let me get the other side. And also,
that looks great.
as good as it gets. And which one did you say? The starboard?
Starboard one might need to stow a little bit, but maybe that was just because of its rotation. Yeah, it hasn't budged. Okay, great.
And I suspect you guys are not comfortable having them deployed.
That's
correct.
Yeah, not while we're, true statement. We could turn them off if they are disruptive.
No, it's more right there, get more light out there as possible. And you might want to check your lower swing arms just to see that they're facing as much straight forward as possible.
As opposed to in?
In or out to the left. At least while we're in this, all this diffusion, we'll try to light up the stuff nearest us.
So you want to...
There's your port upper, so, port lower. So you can try moving that back and forth. And
You just want to rotate it.
Rotate it,
Rotate it.
Rotate it left and right. Take it all the way left for starters. So Rolly, you're looking at my main HD, right? I mean, that's
lower swing arm. There we go, all the way right.
Left.
Yep.
There you go.
We wanted to point them forward, no?
Yeah, now it's pointed into the...
Yeah.
So if you take it all the way to left. Boom. So Rolly, that would be as far out of the center as we can get.
So as you brought it over to the right, right now my left side is at 40% and my right side is at 30% of your main HD camera. As you rotated it over and you actually put it across the camera's point of view, the right side actually got brighter and the left side seemed to stay the same.
Bill, actually.
So would you like it rotated to the right? Is that
so I would say probably rotate it.
Yes.
Why did it just change?
Because the smoke
I'm looking it up right now.
The smoke just drifted off.
Yeah, so the left just dropped down to 20%.
402 meters.
Now the right side is hot.
And now the right's going down to 20%.
So
copy that.
So bringing it up. So we are clearing that cloud layer. And now the left is getting brighter again. So I would say probably that's good with the left, and maybe the right one needs to be tweaked some.
All right. Don, start by pushing the right one all the way to the right.
Okay. That's all the way to the right.
Rolly, thoughts? It probably didn't move. It probably already was all the way to the right.
Yeah, I would have to see right now the light level in the main HD is changing. And it's now symmetrical across. But I believe the right side to be slightly darker.
Okay. Now you're looking.
Well, you have the craft in the way on that side, no?
Yeah, that's true. There's some shadow.
There's some quite a bit of.
But if you want to
metal
rotate
in
that
the
a
way.
little bit to the left on, and
We
see
can
what
try that.
Rolly
Yeah.
thinks of that, you can see it in the mini Zeus right now.
All right.
How much left in our move, Nav?
We have 21 meters, and I wanted to ask you, which side do you want to set up on, or do you want to see what the currents are? Well, it looks like you're being swung around.
Did that change anything really?
To the east there.
Come around a little bit more.
So ideally, you'd want to set up on that side when you start doing your north to south route. Is that correct?
Yeah, pilot. It doesn't need to be north to south. I would choose a direction you feel comfortable with.
Back to the
Okay,
right.
understood.
It doesn't
one. Yeah, Andy, once the
Yeah,
move
it seems
stops,
like
we'll
that's-
see what the current actually is, yeah.
That seems to be the brightest spot.
Okay.
But that side is definitely darker than the left. And pilot, what is your camera up-down angle right now?
For the main
Yeah.
HD,
Yeah.
I am rotated down 10 degrees.
Okay. You want to try getting that object straight ahead just to do a test, floating in the upper right-hand corner?
If I saw it, I would go for it.
It's actually in the darkness now.
Bridge, nav. Well, let's go ahead and hold right here.
So I've got a brightness brighter on the left than the right.
Okay, so now, pilot, if we end up 15 meters at 250 with Sirius, we'll be right over that direction.
Beautiful.
So if however you want to set it up, then we can move Sirius into its final resting spot.
Okay.
And we can start our...
And I'd recommend a shake off of Ash.
Give watch, shake, shake.
Oh, that's a good
watch
idea.
lead, nav. Oh, okay, let's go ahead. Yes. Oh, sorry, hold on. 395. Okay, now go ahead.
I would just give him altitudes. Just give him altitudes because the depth isn't going to be exactly 402 where we end up.
Okay, Don, I'm going to come down.
Okay.
If you could maybe...
you ready to head to the bottom or just come down a little
Copy
bit?
that. I got
get underneath.
Formation underneath you.
Okay, roger that.
If you just hold there.
Yep.
Okay, just real quick. 2, 5, 10, 15, 20, 50, 75, 100, 125, 150.
The last thing I would do would be to center up HD2.
So what I would suggest, Nav, is that you start out finding an altitude that looks comfortable. That's about 2. You might have to go a little higher to just be clear for a transect horizontally, but then work at that constant depth.
Okay.
And then go up to an altitude of 5. And stay at that depth, right? Because the altitude's not going to be constant at a given depth over a transect.
ROV.
Yes.
So and then sort of from there, then you can just work by depth by doing maths from our original depth. But
okay.
Does that make sense?
Yes. So you want me to get 2-ish meters off of the floor there,
right?
From the beginning, and then we want to stay at that depth.
Right, and then reference everything to that.
Yes, and then 5 meters at that depth, constant depth.
Yep.
Yes, I understand.
Shoreside, this is Okeanos Explorer. Someone has their microphone open. If you can mute when not actively speaking, that'll keep the audio level best.
Go watch it.
Yeah.
We're not moving right now. We're setting up for flying. And then we will do one final move, and it's roughly 20 meters or so. We're finding that out right now. So I'll let you know.
Pretty poor, Casey. Just for starters.
And pilots, once again, if you could center up HD2.
I got it.
Okay, thanks.
Do you still want to be over that smoke and sulfur outpour that we saw, though? Copy that.
So go by a previous gas,
Okay,
you'd have that
pilots,
straightforward, but due to the poor visibility, I think I like
the
it.
smoke and
so you can
sulfur that we
see how
saw
much
is right
it is
here.
by having it look at the drawers.
Depending on the currents, I mean,
Is
it
that
could be
good
better.
enough like that, or you want it tipped up a little bit more?
Maybe half the distance up, so we see half the drawer. That's good. And then just square it up a
I
little
think
bit.
we're going to have this plume at this
The plume
depth no
just
matter what.
cleared on the main HD.
Don, can you look straight down with your main HD, please?
Yep.
I think we got the glow.
Pilots, I'm still at plus 18 dB on Sirius gain.
Okay. Pretty smoky here.
Okay, that's 90 down.
Okay, thanks. Pushing forward pretty hard here.
So Nav, what was the thinking behind the additional 20-meter move?
Are you on watch lead 2?
There you are.
Yeah. No, I think I'm survey.
Okay. No, it was just because we didn't know if we were going to be right over it or not, but it looks like he's going to be able to reach it just fine, and it gave us some leeway depending on the plume.
Okay. Yeah, well, I think we may still want to go a little farther northwest to try to get out of the plume, but out of the... Oh, actually, things are better, aren't they?
Sorry, I didn't catch that.
Things are actually better now. Things are
there's a depth right there that we just went through that showed a plume.
Yeah, okay. Okay.
Okay, Don, I'm pushing out in front of you now.
Gotcha.
So tilt up to maybe 45 degrees and then hold, and that'll be my reference.
Gotcha. It's 45 there.
Okay. Great. That's a good position then. Let's continue our way down and make contact with the bottom.
Okay.
All right.
Ready to go?
Yeah.
There we go.
Here we go. Coming down.
All right, folks on shore, we are getting into position and finding a suitable approach where the vehicles have both visibility and we know that we are somewhat close to the plumes. So right now they're making sure that they're going to be able to see each other and fly safely.
And these kind of moves, D2 can go a lot faster than, can it? Than cable. I should be up in the...
You can take that up to 25.
25 then.
Sure.
Okay.
Sure. I mean, as long as you have good altimeter and good visibility on me, and we know where the tether is, that's fine. Did we have steep terrain here, or was this pretty benign?
It was rather benign, but there were some pinnacles. There were some pinnacles.
Okay.
Yep, I can hear you, Amanda.
But it wasn't
and
like
Liz, do we still
the
have you
whole
on the
ground.
line?
There were some flat areas.
Thank you.
All right.
I'm still on the line.
Great.
Okay. So I can see that cloud and
hold on one
to
second,
the left
guys.
of me, 20 meters up.
So in a minute, right before we start, as they're sort of finalizing position, guys, we're going to want to do introductions. Just give us a couple more minutes to let them get in position. Go ahead, video.
$15 meters.
I would say the preference would be to clip them based on the transect. So I can give Annie the list of altitudes that we're going to be going to, so that would be preferable.
That's incredible.
Unless, I mean, for video processing, if we see something that is amazing imagery-wise, a short clip, which will likely be 2 to 5 minutes, is enough that you guys can still clip a highlight image out of that, correct?
Hard return?
Yes.
Hard return. Okay. Coming down.
Gotcha. So yeah, the preference would be for transects or clips that are at the length of the transect and
right
labeled
with
the depths, which I can give you when we start each one.
2006, the edge of it.
Okay.
They're going to be approximately 2 to 5 minutes, would be my guess. Somewhere in that range.
I'm going to slow down a bit here, or stop, actually.
Okay. I see the bottom.
Could you tilt down on Sirius?
Yeah.
Yep.
So Roland.
Follow me now.
Roland, would the preference for video purposes be for me to give Annie the depth of the transect or to give the altitude of the transect?
So the way I remember this terrain when we first pulled up to it,
All
Pilot,
right,
is that the further south we went, it got a little rough, but it was pretty smooth north.
Okay.
we're going to acquire.
Which is consistent with what the sonar says now?
The first pass, and then we will build a reference off of that.
So one possibility
based on
would be to choose
but we will be
our direction.
staying at a consistent depth. So depth will be our consistent measurement versus altitude. So
I did drop a marker exactly on one
all right,
of the
give me a second. I'm going to get a piece of scrap paper so I can write this down.
Looks like if we ran east-west, we might be much better off than.
What is the bottom depth at this spot?
Amanda, right now our depth is just over 400, so we'll begin the first transect around 402. But we're waiting for clarity, and then we will pick a depth and stick with it.
Back into the left.
Back into the left.
So to the east.
Okay.
Current's
Copy that. Okay.
To the east.
That's what we saw earlier.
All right. Great.
Here.
So I think this is really good visibility right here. I don't have an issue with starting to work here.
Great, and it looks like there's some obstacle to our left.
I think that
which
might
would be
the slope.
Yeah, okay, so that would be south of us.
Yep.
Yes.
So I'm thinking work east-west, and we could just ignore it.
Okay.
Hopefully.
I'm good with that.
Then I guess, do you like Sirius's placement for that, or do you want to set it up so we get a large? Is there any particular?
I think it's pretty arbitrary where Sirius is. I'd say we just get started right here.
Okay, then we're going to go ahead down to about 2 meters, pilot.
Okay, now, Casey, do you hear me?
Go ahead, pilot.
Hi.
Hi.
What am I searching for, or am I just moving at a constant speed and somebody else is counting, or what?
So I'm going to repeat the question for OKEX so that they can correct me if I'm wrong. So I'm going to repeat the question, pilot, for OKEX so that they can correct me. Are you latched onto OKEX to hear?
I am on OKEX.
Okay.
So
Amanda, please correct me if I'm wrong, but I'm going to sort of restate what pilot is looking for. So we are going to start at each of these given altitudes. So right now we'll be starting at 2 meters, which you're descending down to now. And we will basically move the length of the tether as far as D2 can go in one direction, and then turn and come back the opposite direction, documenting anything that we see in the water column that looks like a target typical to our midwater surveys. At the completion of the final wrap of the tether, so we go one direction and then come back, we will then move D2 up to the next depth.
And the plan is that we will do an east to west run at one depth, and then a west to east run at the next.
Yes, that's correct. So, Amanda, did I state that properly?
Yes, you did. Thank you.
Okay. Pilot, does that clarify?
Sure. So I'm going to, it's just like a regular midwater transect. I'm looking for things in the water column. I'm ignoring fish on the bottom and things like that.
Correct.
Okay.
Yes, it's the same sort of focuses that you're looking for during a midwater.
Okay.
So if you see something, should you chase it? Yeah, okay. That was a yes.
That was a yes.
Sorry.
Okay.
Yes, chase within your tether length.
Okay. So, let's see here. There we are, looking more or less straight out in front of us. And I'm going to run out to the end of my tether. And then I'm going to turn around and we'll start the first transect. So first I have to go out to the end of my tether just to get there.
And your direction's going to be...
Pilot another...
What you said, Jeff?
280.
280, okay.
No, sorry, the other side.
Watch lead, what was that?
255.
Sorry, Nav, this is watch lead.
Yeah, go ahead.
So we would like to maintain the depth at our standard the speed at our standard midwater speed, which is usually 0.1 knots.
Copy.
Thank you.
Did you copy that, pilot?
I did.
Okay.
All right, shoreside, we are about to start. I'll let you know when we do officially start, but we are at a depth of about 406 right now, and they're just making the final adjustments to the configuration. We can see smoke and venting in the view, but not active bubbling right now, but we are not far from an active vent, clearly.
So, Don,
I'll just follow you with the camera.
You'll follow me until we see the tether get kind of straight, and then I'll spin 180 and come back, and that'll be our first transect as I'm coming back.
So I know we are doing the midwater transects right now, but we are seeing those bottom fish, quite dense populations of those bottom fish on the bottom again, as where we saw them earlier today.
Pilots, are we going to run with the Sirius lights on or off for this?
We can try them on here. Pilot, what do you think? Try the Sirius lights, see what it looks like?
Sure, go for it. See if it.
So have we officially started the transect?
It's good to be able to see the tether a little better.
If that doesn't blow you away, video that.
Pilot, have we officially begun the transects
We
now?
have not. I'm stretching out to the end of the tether, and at that point, I'll turn around and start the first transect back.
Perfect, thank you.
Okay.
So, Liz, we have not quite started the transect yet. They're just getting into final position so we can get a full run of east-west, west-east.
Bridge, ROV nav.
And as
Perfect.
Since we're not on a transect,
I just want to make sure to mark it in the log.
Look at all this
and as the
bubbling coming up here.
Annie is clipping these out, she's going to be putting the depth as well as the east to west,
Hey,
to west
what
to
do you
east.
have as a bailout plan right now?
So if we can ensure we state that before we start each one.
Will do.
Copy. Okay, let's go back to the 300 for this.
So, Amanda, I don't think I mentioned this or not, but I had them add an extra transect or two up at the top so that if we have the time, we can complete them.
Yeah, that sounds good. Thank you, Katie. Spread my mind.
All right, and
I
so
literally lost my cell phone signal as we touched bottom, so I'll keep trying to get that back. But
on the bright side, we have active venting in sight, so this should be a good place to start.
So Liz, I apologize. I'll be relying on you.
No, I think
oh
we do
my
not.
gosh,
Correct,
that's terrible.
But if you tell me what we're seeing, I'm happy to talk about it.
I don't understand, Charlie.
So just so you guys are aware, it looks like our transects will cover, we are fairly close to two vents, two small vents, but looks like the transects will actually cover back and forth over two bubble plumes and a couple smoke plumes. So this should be perfect.
Oh, cool.
I'm sorry, Jeff, I couldn't hear you. The watch lead was too loud for me. What did you just say?
Do you know how to manipulate that graph?
Yeah.
All right. I think I'm stretched out here. So I'm going to turn around.
And what orientation are we going to be going in first?
We're going to be heading east-ish.
East, okay.
We'll call it 080.
All right, so our first transect is starting at a depth of 408, and we are moving east first.
Probably going to come up
Just to keep it interesting, we'll be doing a watch change at 5:30.
I'm not sure how to do that. The only thing.
Okay.
Maybe I'll go eat first and stay, so I can be here for that.
And I'm going to tilt up. Okay, so we're looking in the water column. And here we go.
And we're off.
You might want to mark.
I did.
Okay, thank you.
So is this our official start?
So we have started the first transect.
This is it.
We just have to make sure that the clip cutter gets a chance to put the mark in time.
All right, so our first transect should be titled 408E.
So we're going to do east to west rather than just one letter.
And my forward speed is 0.1. It was 0.14. Now it's 0.12. So just a tiny bit hot.
Now I know how Mike felt when we were doing the transect, but we ended up pre-broadcasting.
Mike is currently out in the mountains today, so he can't connect at all with, I think he's with his son's Boy Scout troop.
So just keep looking both directions. Rolly, you see any critters?
See no critters in the water column yet.
Okay.
It's all bubbles.
Yeah, pretty much all bubbles and smoke right now. for this first one.
Bubbles and smoke.
See lots of flat fish on the surface.
Well, you're not allowed to look there.
Yep.
This has not been thick work.
Yep,
That's
we're
right.
looking for midwater
This is
critters.
midwater. It's just very close to the bottom.
So for those of you that are just joining us at home, this is NOAA Okeanos Explorer, and we are beginning our midwater work.
Clearing
For
the
the next
cloud.
2 hours, we will be exploring, or next actually hour, about an hour and a half or so, we will be exploring the midwater life in the water column just above Daikoku Seamount. So as we move along, we're going to be essentially building a ladder up the water column over some hydrothermal vents that we discovered earlier today. And it should be a fairly interesting exploration of what life lives in the water column over these hydrothermal vents.
Are you rotating, Don?
I am.
Okay.
Just wanted you to get under me, but I'm going slowly, a few degrees at a time.
Got a little scared there.
So far,
Looks like you're about to come to
nothing
the
in the water
surface at
column
this
except for
depth.
sort of what looks like particulate and smoke and bubbles.
But we can definitely see the flatfish on the bottom.
Yeah.
From this few meter perspective.
There sure are a lot of those flatfish.
They're living.
They are just crazy dense.
Wild.
Oh,
right
looks
up
like
in
we
the
have
plume there.
a passing ctenophore. Very small and clear.
So there's been very little work done on the pelagic animals that live in the vicinity of these hydrothermal plumes. And the few studies that have looked at it have found that there seems to be an increase in biomass associated with the edge of the plume and potential
Maybe
influences
are
on the
we
community
tilted at
sector,
zero?
in the general vicinity. So those are things that we're looking for. And
-7.
not necessarily surprised that there aren't pelagic
Maybe we should be at
organisms right
zero
there in
because
the plume.
tend to see more stuff as it gets into the black,
Maybe some pretty toxic
especially those
chemicals
translucent
and metals,
creatures.
in the water that
There's 0.
they might not want
Is
to
that
be near in
something
high
right there?
concentration.
It is.
Snap zoom.
All right, we're zooming in on our first target,
Mucus.
and it looks like it is mucus.
Okay. Full white.
Mucus. Yeah.
Mucus, marine snot.
Yeah,
There's a line on the left. It just swam past.
fairly common
dot
in
at the top
the water
center.
column whenever we do these surveys.
Yeah.
What's that right there? It's falling?
A surprising amount of decaying material in the midwater.
Yep, it's gone.
Okay.
If those white things are near the
What was that?
surface, I won't be able to get it. That's right inside your lens.
Yeah, it's going to hit me. Okay.
There's a lot of benthic stuff up there. You dropped down to. You went up.
There are
to
those
400
tube worms we
meters.
saw earlier on the
I'm
seafloor
staying
too.
at, right now, Rolly, I could not be at 408
Well,
without a shovel. So I'm trying to stay at 2 meters, but I'm not going to be able to do that in casing.
Okay. How much longer in your tether do you have?
Looks like I'm almost stretched out.
Okay.
I can come up over this rock.
Yeah, if you could come up over the rock, that'd be
Sure.
great.
Right.
So there clearly is. So for sure, the pilot is going to come up over this rock. So we're going to have to. It'll be a little bit shallower, but there clearly is some sort of activity there because there are tube worms, quite a bit of them, right over this little broken block.
okay.
Don, am I just about stretched out there?
Looks like it, yep.
Okay.
Well, this will be a good depth to start the second one. 5 meters, huh?
Oh, lovely. Okay.
You are stretched out.
I have a
All right,
black
so we
thing
are
on the
about to
surface.
turn and begin the west to east version, and we started that the past transect at 408, but we had to come up a little bit at the end of that. So, Amanda, would you prefer us to basically drop down and try once we get the ability to drop down to 408, or would you like us to maintain our current altitude right now, which is about 5 meters up?
Let's drop down when we can.
Okay.
So I heard drop down, yeah?
Yes. So, pilot, when you have a chance, please reattain the bottom about 2 meters off and stay there if you can. Obviously, in some areas that's not going to be feasible, but where you can, please do so.
2 meters?
You want the same?
I don't understand.
Yes, similar transect to what we just did.
So another 2 meters.
Just 2 meters.
Oh,
repeat. So we go back in the opposite direction.
Okay.
Oh, okay.
Okay, let's ensure that the clipper is ready to mark her points before we...
Is this going to be what we're going to do every time? Or are we going to go all the way out and all the way back on the same level?
Yes.
Oh, okay.
Okay.
Update.
Okay.
All right.
Wait, maybe not.
All right, coming down to 2 meters.
Yeah.
Wait,
hold on.
What?
Sorry, I'll let you know.
Hold on 1 second, guys. I think I'm getting confused.
Okay, hold
Amanda,
on.
are we supposed to be going back along the same line that we just did, or are we supposed to rise up at the end and then go back? So are we doing west?
The plan was to rise up and go back.
Can you say that again? Sorry.
The plan is to go up, to rise up and go back.
Okay, rise up and go back. I'm sorry.
So we want to stay at 5 meters this time, and the next time 10 meters. Gotcha.
Yeah.
Okay.
Yeah.
So yeah.
Okay. Okay, got it. So I'm coming up to 5 meters, tilting my camera up. Right there. So we're looking level again. And here's 5 meters altitude. Clipper, are you ready?
All right, so this depth will be 396 W2E.
Pushing ahead.
And we are starting the second transect.
One more second, the clipper says.
Holding. And...
And we can look at that swirly thing at the bottom when she's ready to go. Bottom edge of the screen.
If we could zoom in on that, that'd be great.
Pilot, could we get a zoom on?
Yes, as soon as the clipper's ready.
Thank you. Liz, we're going to zoom on it and...
Here we go, we're starting. Rolling.
Okay, let's look at the creature at the bottom.
Center. There you go.
That's mucus.
Mucus. Right full wide.
Looks like it's another mucus.
All right, tilting up level again.
Yeah.
Okay, maintaining 5 meters. Pushing ahead. Dawn, you've lost me.
I see you.
There it goes.
I see you.
It's always good to be optimistic.
I'm up in the cloud.
Yep.
Okay. But I see your lights.
You're at 279
I
degrees.
first became interested in kind of studying these interactions between the pelagic and chemosynthetic environments when there was a workshop at Scripps recently on interactions between chemosynthetic environments and their surrounding environments. And I was invited as a pelagic expert. I knew almost nothing about hydrothermal
Something in the upper
at the
right.
time, but quite a bit about plankton and fish that live in the water column. And when I went to do a literature search on this issue of interactions between these two environments,
Something slightly coming to the center from the left. Top.
This area is clearly a right region for exploration and finding potential new discoveries.
All right, so we have a zoom on sort of a long stick. Not entirely sure what it is.
In black J-shaped almost.
Yeah.
Dawn.
Yeah, go ahead.
I didn't get a good look at it.
I'm going to turn one of these light banks off, see if I can.
It looks fairly solid too, not clear like we often see stuff in the midwater.
I think that was abiotic.
Are all your lights off?
No, just one bank, center ones. I just turned
some off.
I thought I saw them too.
Along at the bottom of the screen.
Tilting down.
And it looks like Scott France is also joining us for our
corner side
midwater work today.
We're moving too fast, or the current's coming at us or something.
Yeah, the current's pushing me.
Okay. And Scott, we agree. We're not sure that that was biological either.
So, co-pilot, have you lost visual contact with?
I have lost visual contact.
You want to try shutting off?
Yeah, I would certainly shut off all your lights.
I'm just wondering what we would do with all biological in the water column.
It's moving around